Okay, this question comes from 5.1. I think 5.1, yeah, this is the only question I got today. 5.1, video question number 1, number 24 online. So this question comes from 5.1, if I can find it. There we go. Let me turn on my whiteboard. And the calculator. I'm going to need both. So first thing I want to do is I want to graph it. I want to see what it looks like. So you can do it by hand, or you can use your handy dandy calculator. Y is equal to the square root, so second square root of x, I got to move it because I can't see it, 30 minus x, 30 minus x, so 30 minus x, close parentheses, okay, then hit plus, I didn't see what it said, hold on, plus 2. Now you can also put the plus 2 outside the bracket if you want to, but plus 2. And delete, 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 delete. You can put the 2 out here and say 2 plus the radical. You can do that. In fact, I'll show you. Go down to the next one. 2 plus the square root, second square root, parentheses, 30 minus x. A lot of people don't realize that they can rewrite it like that. But yeah, graph. And from the previous graph, this is all zoomed out. So let me zoom. And I'm going to try to do zoom fit because that usually does a little bit better. Okay, zoom standard. Six. And that tells us absolutely nothing. So zoom out. And I'm just going to zoom out just to see what it looks like. As you can see, it's decreasing. But the whole point of the whole point of the graph, and that's why I was trying to, let me see if I can do this. Zoom window, zoom box, I call it zoom window, but I'm just going to zoom in the y and the x-axis because that's all I care about. So I'm going to zoom that, and then I'm going to zoom where it crosses the, or where it hits the x-axis at 0. Right in there. And hit enter. So now you get to see a little bit better because you know it keeps on going, but it right in here is your, now why is it sitting up in the air like that? Because from chapter 2 material, that chapter 2 material that I told you was not going away, we're not even addressing the question. What we're doing, if you look at this graph, you see that you got a horizontal shift and a vertical shift. Now, And y'all know that we did this back in chapter 2. F of x is equal to a times x plus h, quantity squared, plus k. And I told you the family of graphs. I gave you the sheet, and I told you to draw it into 7 or 8 sections. And I told you to put y is equal to x. That's linear. Y is equal to x squared, and I gave you and y is equal to the square root, and it looked like a swoosh. All right. Well, this one is going in backwards. It's going backwards. So f of x is equal to a times the square root of x plus h plus k. So first of all, I'm going to turn this around because that's not the way it's supposed to be written. I'm going to say f of x is equal to square root of negative x plus 30 plus 2. I forgot what the vertical shift was. Okay? Now, in order for this to be a positive, it's got to be, it's a positive, so that means it's got to be a negative. So therefore it's a positive. So in this case, since it's a radical, it does move to the right 30 places. Because of this negative right here, if I was to factor this negative out, it would be negative x minus 30, like that. The square root, like that. And then the square root of I, sorry. It'd be I times the square root of x minus 30, which means a horizontal shift of 30 to the right. And here's your 30 to the right. And what does K mean? Back in chapter 2, K means it's horizontal shift of 2 up. 2 up. There's your beginning point. Why is it going the opposite way of your family of graphs? The family of graphs says the square root function goes like this. Why is it going the opposite way? Because of that negative. So, like I said, if you wanted to graph this, your vertex is at negative 30 and positive 2. And that's what the thing tells us. And it's going to look like the family of graphs, only instead of this, it's going to look like this. And I'll do it in red, since it's the opposite of the family of graphs. And we're going to move it 30 to the right, 5, 10, 15, 20, 25, 30, and 2 up. So that's what the graph looks like. And you can see, well, it wasn't there, but I ain't going to worry about it. All right, now, the next thing you need to tell is it's 1-to-1. What does 1-to-1 mean? 1-to-1 means that every x responds to every y. Not every x responds to 2 y's. Not every y responds to 2 x's. But every x responds to 1 x, or 1 y. So that means for every value of x, you get 1 y. The only time you're going to get 2 y's is if you have a what? A parabola. See, 1 y is equal to what? 2 x's. Same thing up here. 1 y is equal to 2, gives us 2 x's. Or a circle. Or hyperbola. 1x gives us 2 what? These are not 1-to-1. This is not 1-to-1, this is not 1-to-1, and this is not 1-to-1. So if you have a line, and that line is either straight or going in one direction and not 2 directions, chances are you're going to have a 1-to-1 function. Okay, a 1-to-1 function is basically anything that looks like what I had up here. It means for every x, I think For every x, there is one what? Y. For every x, there is one what? Y. For every x, there is one y. For every x, there is one y. So that's what a one-to-one function is. For every time you plug in x, you're going to get one y. Now, if you plug in x and get y is equal to 4, and then you plug in x, another x, and get y is equal to 4, then that's not a function. So that's why you're looking for one thing. You're looking for one line or curve in one what? Direction. If you have one line or one curve going in one direction, chances are you're going to have a one-to-one function. So I hope that helps.